Today we are talking about the element cobalt. It is a group 9, period 4, d block transition metal element. It has electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. It has 2 electrons in the 4s orbital and 7 electrons in the 3d orbital for a total of 9 valence electrons. As a transition metal, it has many oxidation states. Most common are the +2 and +3 oxidation states. Less common are the +4 and +5 states. Physical properties. Cobalt does not occur naturally. As the pure substance, cobalt is a lustrous silver-gray color. Average atomic weight 58.9. Density 8.9 grams per cc. It is a solid at standard temperature and pressure, and has a crystalline structure. Melting point 1768 Kelvin and boiling point 3200 Kelvin. Relative electronegativity 1.88. Atomic radius 125 picometers. Mohs hardness 5.0. It has ferromagnetic properties. Cobalt-59 is the only stable isotope. There are 28 radioisotopes ranging from 47 to 75, including 11 metastable states. Cobalt-60 has the longest half-life, whereas Cobalt-49 has the shortest half-life of only 35 nanoseconds. Low atomic weight cobalt tends to decay through positron emission. High atomic weight radioisotopes decay by electron emission. Cobalt-57 also decays by electron capture. Standard reduction potential of -0.28 volts means that cobalt is more reactive than tin, lead and copper, but less reactive than iron, zinc, and magnesium. Cobalt is unreactive in air. At low temperatures, it oxidizes to form a cobalt-2 cobalt-3 oxide hybrid. Above 900 degrees Celsius only the cobalt-2 oxide is formed. Cobalt does not react with water. High-temperature cobalt metal oxidizes in the presence of steam to produce cobalt-2 oxide. Cobalt tends to form dihalides when reacted with halogens. Both hydrous and anhydrous products are formed. It reacts with fluorine gas to form cobalt-3 fluoride. In a similar way, cobalt-2 chlorides are formed. The anhydrous chloride is blue, and the hexahydrate is pink. When reacted with hydrobromic acid, a vivid green product is produced. It is cobalt-2 bromide hexahydrate. It reacts with dilute sulfuric acid to form cobalt-2 sulfate. The hydrate is a red color. Green-gray cobalt-2 nitrate is formed by reaction with nitric acid. Cobalt violet is cobalt-2 phosphate formed by reaction with phosphoric acid. A cobalt hydroxy complex can also be formed by reaction with sulfuric acid. Hexamine cobalt-3 chloride is an orange amine complex incorporating the hexamine cobalt-3 ion. Other coordination complexes are formed such as blue-green copper-2 hydroxide tetrahydrate. World cobalt production is 89,500 tons. Cobalt comprises 0.0029% of Earth's crust by weight. Cobaltite is a common ore which also contains arsenic and sulfur. Safluorite is another cobalt-containing ore which also includes iron and arsenic. Sclerotrudite is similar but also contains nickel. The ore is crushed to a size of 10 mm and then ground to a size of 0.1 mm. Pyrometallurgy. Cobalt sulfides are roasted at high temperature to produce soluble cobalt oxides. Froth flotation is used to separate cobalt oxides from waste products. The shared process is a hydrometallurgical process. Ammonia gas is introduced at high temperature and pressure. Copper and nickel sulfides are removed with hydrogen sulfide. Hydrogen gas is then used as a reducing agent to precipitate 99.6% pure cobalt. Industrial applications. Cobalt is commonly alloyed with iron to produce turbine blades. These alloys have high temperature stability. Cobalt is used in lithium-ion batteries. The cathode is lithium cobalt oxide when fully discharged. Cobalt-60 is useful due to its gamma-ray emission. It is used to treat cancer with Cobalt-60 radiotherapy units. This isotope is also used in food sterilization and industrial radiography. Cobalt is used in electroplating. The plating surface is resistant to corrosion. Biological importance. Cyanocobalamin is also known as vitamin B12. It is the only vitamin to feature a metallic element. There are 4 cobalt-nitrogen bonds in this molecule. Thank you for listening.